Welcome back to another episode of Integration Examples. This is the 8th episode, and each episode has gotten increasingly harder with different techniques chucked in the middle of it. This will be focusing on exponentials for the first one and inverse trigonometric functions for the second one. Two of them, because I'm doing by parts, and if I did three of them, I'd probably be here for about 30 minutes. So two is enough. One example's too short because when I'm looking for help on YouTube, one example just isn't enough, so I figured two was pretty right. Okay, so our first example is going to be fx equals 10 to the power of x multiplied by e to the power of x. Okay, so by parts, we got to pick one to be g dash, and we got to pick one to be f. So which one will we pick to be g dash, and which one will be picked to be f? Well, I'm going to pick ex to be f, and I'm going to pick 10 to the power of x to be g dash, only because ex, it could really go either way, but if you do the derivative of ex, you just get ex. If you do the integration of 10 to the power of x, you get 10x over ln of x. If you derived it, you would get ln of 10 multiplied by 10 to the power of x, I'm pretty sure. But either way, it doesn't really matter which one you do for these. You'll get a pretty, it'll just about take as long. So the rule is f g dash dx equals f g minus integral of f dash g dx. Right. So we have our f, which we said was e to the x, and we have our g dash, which we said was 10x. We need an f dash, and we need a g. Like I said before, the derivative of e to the x is e to the x, and the integral of g dash is, like I said before, 10x on ln of 10. Okay, so here we have the integral of 10x e to the x dx, which will equal this. So f we said was e to the x. G we said was 10x on ln of 10 minus f dash. We said f dash was e to the x of integral e to the x multiplied by g. We said g was 10x on ln of 10. And now we have something to work with. So this would just be e to the x multiplied by 10x on ln of 10 minus the integral of e to the x 10x on ln of 10 dx. Okay, well, I'm going to do two steps here. Because, well, we bring this ln of 10 out, the 1 over ln of 10 out, because it's a constant. But we have an ln of 10 here. So I'm going to bring this out to here, and then I'm going to factor it out of both, because we have 1 on either side of the subtraction sign, the minus sign. So what I'm going to do is have 1 over ln of 10 multiplied by e to the x 10x minus the integral of e to the x 10x dx. Okay, and then we still have this 10x e to the x dx on this side, and see, these two look the exact same. What a coincidence. What I'm going to do is I'm going to try and find a way to get this onto that side and solve from there. But for now, this is in the way, so we have to multiply this onto this side to get rid of it. We have to multiply ln of 10 on both sides to get rid of it. So that'll look like ln of 10 integral 10x e to the x dx equals e to the x 10x minus e to the x 10x dx. Okay, this is good. Now we can get this on this side. Because this is minus the integral of this, if we bring it on that side, it will be plus. Okay? So essentially, we'll have ln 10 multiplied by the integral of 10x e to the x dx plus the integral of e to the x 10x dx. When I'm saying the x, I mean to the power, as you can see as I'm writing. I just don't remember to say to the power all the time. But that will equal e to the power of x multiplied by 10 to the power of x. Okay, now it's starting to get a bit deep. So we can think of this of having an integral of 10 to the power of x multiplied by e to the power of x on either side of the plus sign. So we can factor this out, and that will look like the integral of 10 to the power of x equals e to the x dx multiplied by ln of 10 plus 1. Because if we were to expand these brackets, we would get this above line. And that equals e to the x multiplied by 10 to the x. Okay? Now to get this on its own, we just divide both sides by ln of 10 plus 1. So that way we'll get the integral of 10 to the x e to the x dx equals e to the x 10 to the x over ln of 10 plus 1. And because I didn't add a plus c anywhere, because it would have made things a pain to get through, I'm just going to add a plus c at the end. Because you still need a constant no matter what. But I didn't want to have to carry the c throughout. But there is the answer to the first question. And hopefully a different way of seeing integration by parts. And on the second example, we have a function that equals arctan or arctangent of 1 on x. Or that's the same as saying 10 to the negative 1 of 1 on x. Or the inverse tangent. There's many ways of saying this. But anyway, let's get started. So, now I'm going to show you something that you probably haven't seen. Hopefully haven't seen, because that would make me feel better. But you can write this as arc cotangent of x. Now, why? Well, I saw this and I asked why. Like, how can that, why? And the answer I got was that the cotangent function is defined as the reciprocal of the tangent function. So if you think about it, if we had arccot of 1 on x, that would be the same as arctan of x. So, okay, so hopefully, if you don't understand it, Google it. But, yeah, it surprised me too, but I learned how to do it and now I'm teaching you. So, what we're going to do is we're going to use this because this is easier than this to work with. So if always find the integral of both sides. Now, what we're going to do is similar to how I would solve the integral of the natural logarithm, which I will do in a proof video if you're interested on how you get the integral of natural log. But we imagine that there's a 1 multiplied in, and essentially there is, because 1 multiplied by anything gives anything. So 1 multiplied by arccot of x is the same as arccot of x, but we bring that 1 in because how else are we going to solve this? We're going to solve this by parts, because we're going to say that 1 is one function and arc cot of x is another function. And we're going to say that by saying this here is g dash, so that's the derivative of g, and we're going to say that arc cot x is f. Now the integral of f g dash, this is just the, here's by parts formula, so just writing it out for reference. Okay, so we need n, f dash, we need a g, and we need a g dash. So we already have a g dash, which is 1. The integral of 1 is x. We have an f, which is arc cotangent of x. And the derivative is negative 1 on x squared plus 1. Bang. Okay, so let's sub all this in. So we have the integral of what we started with, which was arc cot x dx equals, okay, f. We said f was arc cot x. G is just x minus the integral of f dash, which was negative 1 on x squared plus 1 multiplied by g, which we said was x dx. Okay. So what I'm going to do here is I'm going to bring this negative out the front, which will get rid of that and make that a positive. And then I'll get rid of this x and bring it on the top, because I'll multiply it on. Okay. Now, what we're going to do to solve this, we're going to need substitution. That was bad, but that's sub. That's supposed to say sub, like Subway. But anyway, sub u in for x squared plus 1. The derivative of u with respect to x is going to be 2x. And to get dx on its own, we're going to have du over 2x. Okay, so we're going to sub this back in up here. So we still got arc cot of x multiplied by x plus the integral of x on u multiplied by du on 2x. So we can get rid of this x, get rid of that x, and we're left with a 1 over 2 multiple in here, multiplied inside. So we're going to bring that out the front, and I'm just going to put quotation marks to signify above, because writing it's pain. Plus, that's going to be a half out the front, and the integral of 1 over u with respect to u. Okay, what's that going to start look like? Well, we're just going to put quotation marks again, and that's going to be plus half the integral of 1 over u, or 1 over an unknown, is ln of that unknown, plus c. Okay. Now is when I'm going to put this back in. So I'm going to have arc cot of x multiplied by x plus ln u on 2 plus c on 2. Okay, I'm going to bring the x out the front of this and have x arc cot x, and well, I'm just going to sub this back in, and we're going to have ln of, what did we say u was? We said u was x squared plus 1. So we're going to put that, x squared plus 1, on 2, and I'm going to say that h equals c on 2. So it's going to be plus h. And so therefore the integral of arc cotangent of x, or arc of tan 1 over x like we originally had, it doesn't matter, they're the same, equals x arc cot x plus ln of x squared plus 1 on 2 plus h. And that is the final answer. Thanks for watching this video. I hope you learnt something, and have a good day.